Okay, so I added more RAM, so this stalling that we're all used to should not happen anymore. And let's see, pen is working. Here we go. So first question, this is on the part that I asked you to use a calculator. Which expression represents 6 more than x? That should be easy enough. 6 more than x. I will translate part by part. 6 is just 6, more than is plus, and x. 6 more than x, and the only answer that represents that is letter C. Next one, evaluate 5x squared. Ooh, this is nice. There's no lag. Hopefully. 5x squared minus 4 when x equals 3. So first thing you should do is substitute. Leave the 5 alone. That's being multiplied. X is 3, and x 3 is to the second power minus 4. Order of operation dictates that you do exponents first, so you leave the 5 alone. 3 to the second power is not 3 times 2, it's 3 times 3, please, which is 9, and minus 4. 5 and 9, multiplication comes first. 45 minus 4 will give you a total of 41. Okay. I like this. Well, now my computer's heating up, but that's okay, because hopefully this won't take that long. Next question. Let x represent any number in the set of even integers greater than 1. Which inequality is true for all values of x? Let x any number in the set of integers, set of even integers greater than 1. So x could be 2, 4, 6, 8, 10, and so forth and so forth. So greater than 1, so x has to be greater than 0. Okay, because the first number that is even and greater than 1 is 2. So any number in this set satisfies this condition right here. 2 is greater than 0, 4 is greater than 0, 6 is greater than 0, 8 is greater than 0, and 10 is greater than 0. It's the only one that truly works. Okay? So the trick here was creating this, a list of even integers. Okay? And you didn't have to go that far, just a few for you to get an idea. Next one. The ratio of the sales tax to the amount of purchase is fixed. It's a fixed number in town Q. The table below shows the sales tax for a purchase of $1,200. So if you purchase something at $1,200, sales tax $72. If you purchase something at $2,500, what is your sales tax? Well, you can do a proportion here. What you do know is that you spend $1,200, your tax is going to be 72. So because it's a ratio, the ratio is all the same, you can set up a portion. So what happens when you purchase something that's $2,500? What are you going to pay in taxes? Now you definitely have to find a relationship here, and there is none right away, so let's pause and think a little bit. What can I do? What can I do? What can I do? Hang on a second. I'm going to pause and think. Pause. Alright, so I did get a calculator. Alright, so 1,200. Here is what you could have done. We're going to scale this down. I scaled it down. You could have done whatever worked for you. And I divide top and bottom by 12. 1,200 divided by 12 gives me 100. So I'm dividing it by 12. Okay, to go this way. And 72 divided by 12 gives me 6. So I'm using this new fraction here, and definitely 100 goes into 2,500. How many times? Times 25. So I'll make another arrow there, but it's going to be times 25. The 100 to 2,500 is going to be times 25. And at the bottom, it's also going to be times 25, and that's going to give us 150. So if you purchase something for 2,500, your tax would be 1,500. I'm sorry, 150, which in this case is letter D. Okay? And what is the cost of an item with a sales tax of 108? Wow, so there's two parts to this question. Well, again, so in this one is a little different. So you have something that cost you $108. So part B. What was the cost of the item? So if you paid 108 taxes, how much was the cost of the item? So again, you can use this same one, okay? Same ratio, 106. Okay, simplified version. Does 6 go into 108 evenly? 108 divided by 6. And yes, it does. It's time 18. No. Yes, it's times 18. So therefore, the top would be times 18. And that's going to give us 1,800, which is letter D. Okay? Page 2. The graph shows the number of teaspoons of water that have dripped from a leaky faucet at the end of X 6 minutes. Which equation represents the relationship between X and Y shown in the graph? Okay. Trick. It starts at 0. So if it starts at 0, it can't be letter D, B. Okay. It has to be either A or C. Those are the only two that will work. Okay. So in this case, y equals 3x, or if you can plug it in, easiest one if you plug it in. So take the first letter, y equals 3x. Okay. And let's take a point, 6 and 2. That's 6 and 2. Okay. And let's plug this in. 1 second, there's something wrong. Oh, I wish I had a pause. Sorry. So here we go. So take one of your equations, and we're taking equation A, y equals 3x. Let's see if that works. Remember, coordinate plane, the first value is an x, the second value is a y, so let's just substitute. It says that y equals 2, and 3 times, and the x value here is 6. You can obviously tell that this does not equal that. So A is definitely not it. B and C, I'm sorry, B we can ignore right away. And you know what? I won't ignore it right away. I'll substitute. I'll show you that doesn't work. So again, we're going to use the same coordinate plane, 6 and 2. So y equals 2, x equals 6. Let's see if that's true. 2 equals 6 minus 3, and that also doesn't work. C, y equals 1/3 x. Well, y equals 2. Oops, how am I doing that? Y equals 2, and 1/3 times 6. Well, 2 on this side, 1/3 times 6. If you put this 6 over 1, on top you get 6, at the bottom you get 3. And guess what? 6 divided by 3 is 2. So the only one that works is letter C. Oh, and based on, sorry, there's a little part here. Based on the relationship, how many teaspoons of water we have dripped in the faucet at the end of 21 minutes. Okay, so now that we know what our equation is, y equals 1/3 x. Okay, at the end of 21 minutes, where's the x here? We can substitute. Okay, so at 21 minutes, we're going to substitute here. Y equals 1/3 times 21. And y equals, again, 1/3 of 21 is just simply 7. Ooh, okay, so I gotta read this, so I'm gonna press pause for a second. Okay, so aquarium. So there are going to be 2 aquariums. Now let's draw one over here. And we're gonna put 200 gallons of water in here. And we're gonna put 200 gallons of water in this other aquarium. So this is going to be for small fish. And this is going to be for big fish. So it says here that Sam is going to buy 5 small fish. So 5 small fish for every 10 gallons of water. And on this side, so we want to find out how many fish is going to go in here in total. So if it holds 200 gallons of water, how many small fish can we get? Very easy. The relationship from 10 to 200 is times 20. So times 20 over here, you get 100 fish. So you're going to fit about 100 fish in here. Now on this side, on the big one, it's 8 fish for every 40 gallons of water. And because we have 200 gallons of water, let's see how many can we... The relationship here is 40 times 5 times 5 as well, so you get 40 fish. So inside this aquarium, obviously, because fish are bigger, you have to get less of them, 40 fish. And what's the ratio of small fish to large fish? Well, we're going to have, the ratio is going to be for every 100 fish, small ones, you're going to have 40 big ones. Okay? Again, let me pause so I can read. Okay, so let me try to so I'll draw that. So here we go. And we know a couple of things, that this is point P. And we know that it's called N and 3. I don't know what the X coordinate is, but I know what the Y coordinate, and I have a point R over here. That's what's given. So, and they also tell you that there's a point Q at blank. We don't know where in the X, left or right it is, but I know that as far as it's somewhere at -2. So point Q is somewhere here. Okay, and I'm gonna draw where point Q could be. Anywhere on that line. Left or right, I don't know, but it's down 2. Okay, the other thing I know is that the distance from point P to point Q is equal to the distance from point P to point R. Well, the distance from point P, right here, let me change it. This distance from here to here is the same distance as this point P is equal to this point P. What's the distance from this one to this one? Okay, ooh. Did I read something wrong? 1 second. Alright, so I did this drawing wrong, so I'm going to start this problem again. I'm going to erase everything. This is not my eraser, this is my eraser. So I'll make it a little bigger. So let me just draw it again. It's not as complicated. It's just I read it wrong. Here we go. So I will draw exactly what you have on your screen, which is something like this, only straighter. And you know that there is a point P somewhere over here. We know it's 3 floors up from the origin, so if this is the origin, I know it's 3 up, but I don't know how far right it's going. And there's a point R here that we know it's still 1, 2, 3 up, but again, we don't know how many to the right it is. Okay, the other piece of information that I know is that there's a point Q somewhere, and point Q, I know how far down to go, 2, okay, that's where my point Q is, and apparently point Q is the exact same distance, this distance right here, and I'm going to create a line. Where's my line? I'm going to create a line. I'll create this line. So point Q, let me back up a little bit. Point Q, and I'm going to take this, clone it. Nope. I'm just going to clone one right there on the side, and see if I can turn around. I can. Alright, so point Q is exactly the same thing as this, is exactly the same distance away from, it's exactly the same distance P and R are. But point Q has to be 2 flights down. It's the only place, because it does have to be somewhere here, 2 flights down. And to go 2 flights down, how do I know? And let's see if I can move this around. It can't be there, it can't be there, it can't be there. It has to be here because it says that point Q, okay, is somewhere -2. So because it's the same distance, so this here and this here, the same distance, it puts us at this place right here. And I can figure what this is. Okay. Why am I writing it again? But I will. Okay. So if we're on 3rd floor, imagine if you're on the 3rd floor and you have to go all the way down, all the way to the basement. Actually, not the basement, but 2 floors underground. You would go 1, 2, 3, 4, 5. So this distance right here is 5. Okay. If that distance is 5, guess what this distance has to be? It has to be 5 as well. So now that we know what distance this is going left and right, so that would be 0, 1, 2, 3, 4, 5. So this guy right here is a 5. It's if you start at the origin, you go 5 to the right and 3 up. That's the location of point P. Okay. I have some room here. Okay. James has a board that's 3/4 foot long. He wants to cut the board into pieces that are shown 1/8 foot long. How many pieces can he cut? Blah blah blah. How can explain how James can use the number line diagram to determine the number of pieces he can write an equation division that represents how James can write an equation. So I'm going to start with part B here first because the equation is a little bit easier. So the equation, the number of boards that he can cut, so the number of boards, and we'll present that by n. Number of boards would be 3/4, which is how long the whole board is, and we're going to divide it into what? 1/8 pieces. Okay. Now, to use the number line, how do we use the number line? Uh-oh. Feel a little drag coming. Alright, so we have 0, 1/4, 1/2, and 3/4 right here, and 1. Okay? 1, 2, 3, 4, 5, 6, 7, 8. So they're also broken into 1/8. So each segment here, okay, I'm going to change colors. From here, this is 1/8. This is also 1/8. This is also 1/8. This is also 1/8. This is also 1/8. And this is also 1/8. How do I know it's 1/8? Well, because from here, from 0 to 1, we broke it up into how many pieces? 1, 2, 3, 4, 5, 6, 7, 8. So each piece is 1/8. So now it doesn't have 1. He only has 3/4. So if you have 3/4 and you divide it by 1/8 pieces, you would get 1, 2, 3, 4, 5, 6. Prove it. Let's use our equation. 3/4 divided by 1/8. N equals 3/4. Keep that, and we're going to multiply it by our reciprocal. 8/1, and 3/4. 3 times 8 is 24 on top. At the bottom, 4 times 1 is 4, giving us a total of 6. And that's what we have. 1, 2, 3, 4, 5, 6. Okay. Page 3. Ooh, yikes. Let me read this again. Okay, so bottom question, the cubes. Let me just sort of draw this. I can draw the whole thing. Okay. Now that first lay over here. Okay. Okay, it's not going to be accurate, but I do know that there is 9 going across. Okay. And there is, I believe, 7 going that way. Okay. So remember, volume, and in this case, we're using this particular formula. The area of the base, on the top here, you have 63 cubes. The height, the mistake here was that the height, instead of 10, she used 9. Okay, the height is 10. Okay. So this should have been 630 instead of the 567 that she thought it was. Okay. 27 goes to 54, 55, so there's times 10. Okay, so that's right. So volume, it's the area of the base, so the base on the top. Okay, there are 63 cubes, and the height's 10, so 630. What's the cubic inches? Okay, and then at the bottom, a second box has an area of base. So again, another box. Okay. Okay, so the base area, and then contract to the picture. Let's just put 63 here at the bottom. So the area of the base here at the bottom is 63, but it has a volume of 70. Ooh, tricky. It has a volume of 756. What is the height? So let's start with the formula. V equals big B times H. The volume itself is 756. The base here, the base area, the base is 63, and we're missing the H. So this case, all right, becomes an equation. You know that you're supposed to divide, okay, 756 by 63. It's a multiplication equation, so you can divide both sides by 63. Remember, divide that by 63, and we're also going to divide that by 63. This is going to cross out. I have H, and 756 divided by 63, it's going to give you 12. So the height of our cube, of this new cube, is 12. Okay. A group of hikers buy 8 bags of trail mix. Each bag contains 3.5. So 8 bags of trail mix. All right, 1, 2, 3, 4, 5, 6, 7, 8, and there's 3.5. Each bag has 3.5 cups. So this one has 3.5 cups, 3.5 cups, 3.5 cups, 3.5 cups, 3.5 cups, 3.5 cups of trail mix. The trail mix shared. Okay, so they bought all that. There's 12 people. How many cups of trail mix? Okay, so how many cups of trail mix will each hiker receive? Well, first we got to find out how many total we have. We have 3.5 cups times 8 bags. So let's figure out how many cups we have. First of all, change to an improper. 3 times 2 is 6 plus 1 is 7. 7.5 times 8. And we got 56 over 2, and 56 over 2 is 28. You got 28 total cups of trail mix, and there's 12 hikers, so 28 divided by 12. Okay. Hopefully we got a nice number. 28 divided by 12. If you use a calculator, you're gonna get a decimal. But if you don't use a calculator and you do it like this, 28 divided by 12. 12 goes to 28 2 times. 24, 4 left over, and 12, and you're gonna get 2 1/3, which is the nicer answer. You don't have to deal with any decimals and worry about rounding. Okay. And last question. Brianna's teacher asked her which of these 3 expressions are equivalent to each other. Hopefully, everybody got that was a plus sign. Let's see. Brianna says that all 3 expressions are equivalent because the value of each one is plus 4 when x equals 0. Let's see if that's true. Brianna's thinking is incorrect. Identify the error in Brianna's thinking. Determine which of the 3 expressions are equivalent. Explain or show your process. Okay, give me a second. Alright, so first of all, let's figure out how she got 0. So 9x minus 3x plus 4, that's one expression. The other one was expression B, which is 12x plus 4. The last expression was 5x plus x plus 4. So when it's 0, you get 9 times 0 minus 3 times 0 plus 4. 9 times 0 is 0 minus 3 times 0, which is also 0. So 0 minus 0 is 0 plus 4. And 0 plus 4 is 4. 12 times 0 plus 4. 12 times 0 is 0, so that's 4. 5x plus x plus 4, that's 5 times 0. plus 0 plus 4, and you get 4. So actually when x equals 0, all the answers give her 4. Okay, it's wrong because I have no idea what she did, but it's definitely, I don't know how she got 0. So that's A, incorrect. B, does that mean they're all equivalent? You have to be careful here. Okay, so let's go back to the first expression. 9x minus 3x plus 4. Remember, to be equivalent, the expression has to be exactly the same. 9x minus 3x, let's make this a little shorter, okay? Combine what we can. 9x minus 3x, I can combine. So I can combine these two. And 9x minus 3x is 6x plus 4. Okay. Here, 12x plus 4. That this is 12x plus 4. Can I combine anything? No, I can't. So that is my final answer, 12x plus 4. This was 6x plus 4. This is 12x plus 4. Last one, 5x plus x plus 4. And I can combine these two. 5x plus x is 6x plus 4, and there's nothing else I can do. So, truly, the only two expressions that are really equal to each other are this one, the first one, and the last one. I know the answer gave 4 for all three expressions, but if you substitute something different, okay, and I'll show it to you. Let's try when x equals 2. When x equals 2, you get 6 times 2 over here, plus 4. 6 times 2 is 12, plus 4 is 16. Okay. Here, when x equals 2, you get 12 times 2, plus 4. 12 times 2 is 24, plus 4 is 28. See, your answer is already different. This gave you 16, this one gives you 28. And the last one, 6x plus 4, you get 6 times 2, plus 4. And 6 times 2 is 12, plus 4 is 16. So again, you get 16, which is exactly what you got in the first expression. So the only true equivalent expressions are the first one and the second one. Okay, this one gave you the same exact answer when we chose x equals 0, but that only worked for that particular value. Okay, stop. Okay, so, and that's that. Okay, hopefully that helped a little bit. Okay, I'll be loading up. It's 10:13, should be up by hopefully 10:30 or so, depending on YouTube.